Hi everyone, welcome back to the Pre-Cal 40S videos. In this one, we're going to look at the second part of T2, and we're going to do some work with similar triangles. All right, so if you recall this here, Pythagorean Theorem from previous years, you have a squared plus b squared equals c squared. And we can also write that equation in terms of x, y, and r. So if we look at this here, this is going to be our distance x. And this is going to be our distance y. And then here, this line, this hypotenuse of the triangle, is going to be our r. Now, in this question, it says the point P lies on the intersection of the unit circle. So this is the unit circle, okay, where the radius is 1. And our line joining the origin to the point 4,3 is this one right here. Now we're going to try to find the coordinates of P of theta. Now in order to do that, we're going to use this fact here. So P theta is equal to cos theta and sine theta. And that's your x and y coordinates. So we're going to do that with right here. Now all I need to do is take the values of x is 4 and y is 3 to figure out my radius. So this is the 3, 4, 5 triangle. So if you can do this and you know that the answer is going to be 5, that's great. Just by plugging in the numbers here, if I plug in x equals 4, so I've got 4 squared plus 3 squared equals r squared, and then solve everything for r. So you've got 16 plus 9 equals r squared, 25 equals r squared. Then you square root both sides, and your answer for your r, for this radius right here, is 5. Now we're going to say it's only the positive 5 because it's in the first quadrant, and the radius has a positive value. It's not going to have a negative value in your questions. The only ones that are going to have a negative and positive value possibly are the x's and the y's because of the coordinate plane right here. If the point was over here, then we would consider a negative x value. And if it was here, we would consider a negative y value and a negative x value. If the point was in this quadrant, we'd consider a positive x value and a negative y value using the cast rule. All right, so now we can just say that our p theta is going to be 4 over 5 and 3 over 5. Now, why is this the case? Well, if you recall, do you remember this idea here? Cos theta is equal to adjacent over hypotenuse, and sine theta was equal to opposite over hypotenuse. So if you relate that to this triangle, it gives you these answers. Okay, now let's look at example 4. Example 4 says the point P theta lies on the intersection of the unit circle joining the origin to the point -3, 6. Find the coordinates of P theta. So same idea as the question before, but now we've got our point in this quadrant here. So let's figure out, let's use a squared plus b squared equals c squared, just for fun now, and plug in our information that we have to get our radius, which is what we're missing. So 36 plus 9 equals c squared, and you've got 45 equals c squared. Now we can say that c is going to be the square root of 45, and leave your answers in exact form. If you want, you can reduce the radical, but in this case, I don't think, well, it's completely necessary. It would be, let's see, 45 is 9 times 5, so I would have 3 root 5. That would equal c. Okay. Now we've got to write it in our p theta form. Cos theta and sine theta. Okay, so now we can do, let's see here. So this is adjacent over hypotenuse. So this is my triangle that I'm looking at. So what's my adjacent? My adjacent is going to be the -3, and my hypotenuse is 3√5, and my opposite is going to be my 6. So that's 6 over 3√5. So I can reduce it one step further and write -1 over √5, 2 over √5, and if I want to rationalize it, then I'd have -√5 over 5 and 2√5 over 5. All right. This last example here, find the missing circular functions for where theta, for theta when one function is given. All right, so in this one, what we're going to do is we're going to note that sine theta is equal to -3 over 5. So this, we can remember that this is going to be opposite over hypotenuse. So which thing is missing? Our r is missing, so we can figure out the radius, or also I could think of it as the adjacent side. All right. So now, when we're doing this, let's kind of get a little bit of a diagram of what it looks like. So where is sine negative? Sine is negative in the, so we've got our cast rule. So it's negative in here and here. So I'm going to have this being somewhere here and here. This is what my sketch, just to give me an idea of what it's going to look. I'm going to have an x value that's negative here, an x value that's positive here. My y's are both negative over here. All right. Now, when I figure this one out, I've got opposite and hypotenuse. So here, this can also be my y and my r. So I can figure out what my next part's going to be. If I look at it like this, it's going to have my theta's here, my theta's here. Okay, so r squared equals x squared plus y squared. And I know my r is 5. 5 squared equals, and then x squared plus my 3 squared. I'm going to ignore the fact that it's negative. I'm going to deal with the negative with the cast rule. And then I know this is a 3, 4, 5 triangle. So x is equal to 4. And my answer is going to end up being, I have to write down cos and tan. So let's have the answer for cos theta, which is going to be 4 over 5, that's x over r, and tan theta is going to be -3 over 4, which is my y over x. Okay, now this is going to be negative because considering I need to make note that I was only really caring about the answers that lie in between here. So 3 pi by 2, and between 3 pi by 2 and 2 pi, so that's going to be, so from here to here is pi, right? So that's the same as 2 pi by 2, and this is going to be 3 pi by 2. So really I'm only considering my answers within this area right here. So in here, cosine is positive and tan is negative. So cos is positive and tan is negative. So that's why we stick with this right here. All right, so here's some homework for you guys to try. Good luck, and remember the cast rule. We'll see you soon.